why Tesla needed the Giga Press. But before we start, I would want you to hit that red subscribe button so that you never miss out on any of our videos. So guys, we all know Tesla is a company with a big goal, one which focuses on the master plan of its CEO. So far, Tesla has pretty much completed Elon Musk's first master plan. But part dough still needs some worth to accomplish. This is especially true for one aspect of the CEO's target: expanding the company's vehicle product line to address all major segments. So far, Tesla has vehicles that compete in the large sedan, mid-size sedan, SUV, and crossover market. This is one of the reasons why there is still so much more for Tesla to do. Granted, the Cybertruck will address the pickup market, the Semi will address the long-haul segment, and the new Roadster will compete in the supercar market. But there are still other segments to tap. One of these is the compact car market, which is populated with small, low-cost vehicles that are extremely aggressively priced. Tesla and Elon Musk have both noted that the company will be producing a $25,000 electric car that is smaller and cheaper than the Model 3. Such a vehicle would likely be equipped with the best innovations that the company can offer for it to be profitable. These include low-cost and disruptive tabless 4680 battery cells and massive single-piece casts that are produced with the Giga Press. And considering that both Giga Shanghai and Giga Berlin seem poised to produce the $25,000 Tesla, there seems to be a good chance that the company's Giga Press platoon is only bound to get bigger in the near future. You all may know that in recent years, Tesla has been focusing on casting technology to produce larger parts of its vehicles in bigger pieces. Tesla is now producing the Model Y with one giant rear underbody that used to be made of 70 parts. That's possible due to Tesla's first Giga Press, which was installed at the Fremont factory and put in operation last year. The machine, nicknamed Giga Press, is the first of its kind and is produced by Giga Group in Italy. It has a clamping force of 55,000 to 61,000 kilonewtons. Tesla introduced another of those massive machines at the Fremont factory in September. Tesla has since reportedly ordered many of those machines to deploy at new factories. More recently, we reported on Tesla taking delivery of a Giga Press at Gigafactory, Texas. They are described as the biggest casting press machines in the world, and Tesla is trying to deploy as many as they can. We all know that current automobile chassis are made up of tens or hundreds of individual parts, which are made of many different materials and must be joined together in several different ways: welds, bolts, and adhesives. Tesla's plan is to use two huge single castings for the front and rear underbody sections, and to connect them with a battery pack that serves as part of the body structure. This innovation reduces weight and greatly simplifies vehicle assembly. Cast components are a staple of auto manufacturing, but the norm is to cast smaller parts, which are then assembled into larger structural elements. As Elon Musk tells the story, one day he was considering a die-cast toy car on his desk and wondered what the practical size limit for casting would be. After some research, he learned that there really is no size limit, and decided to fabricate the front and rear underbodies of a vehicle as two huge castings with huge machines made by Giga Group. So far, Tesla has set up two Giga Presses on the grounds of the Fremont factory. Flyovers of the site show that the two machines are already set up, though it remains to be seen when they would formally be deployed. Over in China, 3 other Giga Presses have been spotted in the Giga Shanghai complex, though the units were reportedly built by LK Machinery, Giga's parent company. But what is rather remarkable is that Tesla has several more Giga Presses in order. Sandy Munro, in a recent interview with electric vehicle advocate Sean Mitchell, noted that he has heard through the grapevine that Tesla has ordered 11 more units of the Giga Press. Previous reports point to Giga Berlin receiving 8 of the machines, and flyovers at the Giga Texas site seem to reveal 3 isolation pits for the monster machines in the area. Needless to say, the Giga Press is poised to become a key part of Tesla's Gigafactories from now on, as Tesla rolls out its single-piece cast design for the vehicles in its lineup. The company's platoon of Giga Press machines will likely play an even bigger role. This role will likely become prominent starting next year, 2021. Now, what do you think would be the benefits of single-piece casting from Giga Press? Giga casting will help achieve a 40% reduction in rear underbody cost savings. Also, the new single-piece casting design will deliver a 30% reduction in the size of the body shop. JP Morgan points out that Lori Harbour, president of Harbour Results Incorporated, a manufacturing consultancy firm, estimates that Tesla could save about 20% on labor costs from the single-piece casting. Using the GigaPress also eliminates alignment problems caused by the combination of several smaller parts, resulting in higher quality vehicles. A larger die casting machine is expected for Tesla Cybertruck production. At Tesla's Q4 2020 earnings call, Tesla CEO Elon Musk commented that it would need an even more powerful high-pressure die casting machine with a clamping force of 8,000 tons for the production of Cybertruck. Assuming the casting machine produces one body part every 4 to 5 minutes, around 70 to 90,000 units of annual production can be generated from one GigaPress. Given 2 GigaPresses are needed for each Model Y, one front body, one rear body, it is estimated that around 8 to 10 GigaPresses are needed for the production of 350,000 units of Model Y. Now the question is, will other automakers follow? Tesla's Giga casting is a radical change to the traditional automobile production process. If one were to follow, new capex investments are needed aside from drastic changes to vehicle design, production process, and management. JP Morgan thinks EV startups or Chinese brands may be the first to follow Tesla's footprint. Tesla has always been a rebel of sorts, and this became extremely prominent this year. 2020 will likely be known as the year when the world stopped, and automakers suffered deep wounds due to the pandemic. Tesla, being a company that has always swam against the current, thrived instead of dropped. It is even poised to end the year as the new member of the S&P 500. But 2020 is only the beginning of a new chapter in the Tesla story. With the company now on more stable footing, the electric car maker can focus on executing its ramp for 2021. This ramp would likely involve Tesla aiming to produce close to or perhaps up to 1 million vehicles in 1 year. Such a ramp would require the full deployment of its GigaPress machines. There is little doubt that GigaPress number 1 and number 2 at the Fremont factory will be deployed fully soon. GigaPress number 3, number 4, and number 5 at Gigafactory Shanghai will likely be operational in early 2021 as well. And with Gigafactory Berlin likely starting Model Y production sometime next year, there's a good chance that several of its GigaPresses would go live next year as well. These, as well as the speculated machines in the Cybertruck Gigafactory in Texas, should allow Tesla to turn 2021 into the year of the GigaPress. Now, what will be the principle of operation? Die casting works by forcing molten metal alloy inside a reusable mold, then opening the mold to remove the finished piece after it has solidified. The open mold is cooled to 185 degrees Celsius and cleaned by robots, and fresh molten aluminum is prepared for the next cycle to begin 1 to 2 minutes after the first cycle. Each fresh casting is trimmed to approximate size, measured, checked for imperfections, and sent for CNC machining to finish size. For the Tesla's GigaPress-based casting operation, ingots and offcuts of aluminum are melted in a natural gas-powered melting oven operating at 850 degrees Celsius. Slag in the form of aluminum oxide is mechanically removed from the surface, and the rest of the liquid metal is pumped through the heated pipes to an enclosed warming oven operating at 750 to 850 degrees Celsius, heated using 400 kilowatts of electrical power. To prevent the formation of oxides, a tank blanket of nitrogen gas covers the molten aluminum, which is circulated to maintain an even temperature. Argon gas and a rotary degreaser are used to remove impurities, with a silicon carbide filter removing most other particles larger than 25 micrometers. At the beginning of each casting cycle, robots spray 35 milliliters of soybean oil in a thin layer inside each half of the mold to allow separation. The mold is closed and a low vacuum of 50 millibars is created by pumping out the air from inside. A precise amount of molten metal is pumped from the holding oven into the casting chamber of the GigaPress at 750 degrees Celsius and forced into the mold using a high-speed plunger with an additional 8 milliliters of lubricant. The mold is opened and the raw casting removed at 400 degrees Celsius. A robot reaches in and removes the casting, placing it in a quenching tank to reduce the temperature from 400 to 50 degrees Celsius. A mechanical trim press cuts the approximate edges with excess aluminum being recycled back into the melting oven. The remaining useful part of the casting is X-rayed to check the internal structure, trimmed by laser, drilled for fittings, and then computer measured for accuracy. So guys, that's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing videos from us.